Assalamualaikum. My name is Amibul Nashrik bin Amibullah. My metric number is 073721. We from group 2. We want to present instruction pipeline from our class CSF11203 Computer Architecture and Organization. And this is the list names and the number of metrics for our group member. So let's get started.
Assalamualaikum. Today I want to present about instruction pipelining. Pipelining is the process of storing and prioritizing computer instructions that the processor executes. The pipeline is a logical pipeline that lets the processor perform an instruction in multiple steps. How pipeline works? First, a useful method of demonstrating this is the laundry analogy. Second, for loads of laundry that need to wash, dry and folded. And lastly, what is the most fastest way to get the 4 loads of laundry done?
As we can see, this is 6 stage of instruction pipeline. First stage is fetch, the second stage is decode, and the third stage is register read. The fourth stage is execution, and the fifth stage is data memory, and lastly, the stage is write back.
Okay, thank you for Mr. Aiman for presentation of the instruction part 1. Now, I will continue to the next instruction part 2. Now, we have this flowchart of the instruction pipeline. There are 6 the instruction pipeline. The first is a fetch instruction, and then a decode instruction, and then they go to the calculate operand, and then we have unconditional branch. If the comment say yes, and we straight to forward to update PC, then it says now we go to the next pipeline. The next pipeline is a fetch operand, execute instruction, white operand, and branch or interpret. If we comment no, we go back to the fetch instruction, and we say yes, we go to update PC. The update PC then go to empty pipe and go back to fetch instruction. This is another flowchart of the pipeline online instruction. You can see the time gap between instruction increase very significantly. Instruction of pipeline of 9 instructions. The figure above show you how the pipeline instruction reduce the processing time of the single instruction and improve the efficiency of the system. Notice that the instruction decode stage of instruction 1 is overlaid with the instruction fetch stage of instruction 2. This is noticeable how the instruction pipeline speed up the processing time of the processor. Like when the instruction execute sequentially, only the 2 instructions are executed in a 10 clock cycle when the instruction or pipeline 5 instructions are executed in 9 clock cycle. That's for me. Thank you.
Pipelining performance. Pipelining increases throughput, not reduce the execution time of an individual instruction. In phase, slightly increases the execution time and instruction due to overhead in the control of the pipeline. Practical depth of a pipeline is limits by increasing execution time. Unbalanced pipeline stage overhead, pipeline register delay, clock skew. This is the formula for pipelining performance. CPI is always an average over a large number of instructions. Formula of processor performance: CPU time equal to instruction over program times cycles over instruction times time over cycle. Instructions per program depends on source code, compiler technology and ISA. Cycles per instructions CPI depends on ISA and architecture. Time per cycle depends upon the architecture and base technology. This is the example. example question for pipelining performance. As you can see, there is calculation for the average instruction execution time on the pipeline processor and speed up from pipelining. This is the formula for speed up from pipelining and CPI pipeline.
Instruction pipelining hazard. The instruction pipelining hazard is a condition where the execution of the pipeline instruction is stopped or delayed. It is also called as a pipeline bubble. There are three kinds of instruction pipeline hazard, which is the first one is resource, second one is data, and the third one is control hazard. Okay, for the first one, resource hazard, when two pipeline instruction or even more want to access the same resource, it will result in resource hazard. It is also termed as structural hazard. A solution to this hazard that this instruction must be executed serially up to some portion of the pipeline. For the data hazard is a condition when accessing an operand location create a conflict, and an instruction source operand are used by a prior instruction but still in the pipeline. And then for the control hazard is an attempt to make a decision about program control flow before the condition has been evaluated and the new PC target address will be calculated. And then control hazard only occur when instruction pipelining fails in predicting branches in the instruction.
Assalamualaikum. My name is Amirullah Shfiq bin Amirullah. I'm in Book 2 and I want to talk about the advantage of instruction pipelining. The first one is reduces the processor's cycle time. This is because it can process more instructions simultaneously while reducing the delay between completed instructions. The second advantage is instruction pipelining can increasing instruction throughput. The third advantage is the instruction pipelining that all the stages includes fetch instruction, decode instruction, calculate operands, fetch operands, execute instruction, and write operands to execute an operand store to be performed in a parallel. The fourth advantage is in every clock cycle, an instruction completes its execution. The fifth advantage is more faster of ALU, which is arithmetic logic unit, can be designed when pipelining is used. The sixth advantage is pipeline CPUs works at higher clock frequencies rather than the RAM. The last one is pipelining increases the overall performance of the CPU. And I think that's all for the advantage of instruction pipelining. Thanks for watching.